Hello, this is Divas. Here is my student ID, and following is the video presentation for assignment of algorithms and data structures. Here in task one, I have my word class with me. What it does is it stores the literal word along with some important properties of it. For instance, we store the frequency, which measures how many times we have encountered the word, and its list of neighbors, which are all the words that are of the same length and differ by only one character. I have some utility functions, for instance, increase frequency, which takes which increments the frequency of a particular word whenever we encounter it. Um, it also has print neighbors. What this does is this returns a comma separated string representation of all the neighbors of one particular word. Um, I also have overridden some of the special functions such as string functions. What this does is it returns the string representation of a word object. It returns it in a nicely formatted manner. For instance, in the formatted string, it contains the word, its frequency, and print all the neighbors of that particular word. Um, I also have some special comparison methods. For instance, less than. What this does is if it takes two arguments, self and other, and if self is less than other, meaning the word of that instance is less than the word of other instance, then we return true. Otherwise, we return false. There is also some type checking so that if we provide a instance of another class, it won't process it. It won't return true. It won't throw an error. Similarly, I have equality method. What it does is it checks whether self and other are equal or not. There is some type checking over here as well. And I also have less than or equal to comparison special method. What this does is it checks whether the word is less than or equal to the other word. There is a type checking over here as well, and we already utilized less than operator, which we defined above. Finally, there is the isNeighbor function. What this does is for any given word, it checks whether other is a neighbor of that word or not. And the rules for being neighbor are just it must be the same size. So if it's not the same size, we return false, and the difference should be equal to 1. If it's more than 1, we return false. Let me just run my code for task 1, and it runs without any error. Moving on to task 2. For creating the lexion, I store it as a list and as a list of words. Uh, for the read data function, what this function does is it takes the word where we should store our words and the file name where the data set is located. It iterates over all the line in that file, and for each line, it converts all the characters into lowercase and then splits it. By splitting, we store all the words as individual elements in an array and assign it to line. For each of the word in the line array, what we do is we apply filter which removes non-alphanumeric characters. If after removing no removing if after applying a filter, the word is empty, that means the word was invalid earlier, and we should just skip it over. After that, we iterate over the word, and if the word has already been encountered before, we simply increase the frequency. Otherwise, we append it to the list. Here, I just load the data set um, into the function, and let's run this. This runs without any errors. For task 3, for the part 1, I have chosen insertion sort because it is simpler and gives us a good time complexity of in a best case, a good time complexity of uh, log of n, especially when the data set is smaller, which will be the case in the hybrid function, hybrid sorting algorithm. So what this does is it starts from second position and assumes the first position is already sorted. It takes key as the second position and iterates over all the previous indices. And if the previous indices are greater than key, then it shifts those previous indices by one. And after this condition has been proven wrong, then we can safely assume that we have found the correct position of key, which is j plus 1, at which point we simply assign it. So this is the first sorting algorithm. Let me run it. Yes, it runs without any error. And for the second sorting algorithm, I have combined two algorithms, insertion sort and hybrid sort. Let me start from here. This is the wrapper function. It essentially takes the word and performs and calls the hybrid sort algorithm, which is the main sorting function here. It takes words, the beginning and the total length of the length of the array. What this does is it checks what this is basically a merge sort. So first it checks whether the array can be partitioned or not. If it can be partitioned, then it means we have already reached the base case. And one important modification over here is each partition it checks whether we have reached the threshold size or not. If we are below the threshold size, then we simply call insertion sort because insertion sort is more efficient with data sets of lower size. If the threshold has not been reached, it simply again partitions the array. It finds the midpoint and partitions the left side until only one word is remaining, partitions the right side similarly, and merges those two partitioned sides. At the merge function, what we do is we create a temp array. We create two pointers, I and j, representing the starting point of those two partitioned subarrays, and we iterate over those partitioned array until one of them is empty. At each iteration, we check which one's the smaller, and then append the smaller one, increment the pointer representing the smaller one. After we have finished this, we know that one of the subarray is empty, so we simply fill up the remaining subarray into the temp array. Let me just run this, and this runs without any error. For task 4, uh, I have my select sorting algorithm function, which gives users the choice to choose between two sorting algorithms, insertion sort and hybrid sort. If they choose one, it performs insertion sort, otherwise it performs hybrid sort. If they choose a invalid option, it simply asks them to choose again. This is for resetting the lexion. It resets the list and again loads and again populates the data. So let me try this again. Let me try merge sort. I select two, and yes, it basically sorts the array. Moving on to another. For populating the neighbors, what I do is the add neighbors function populates the neighbors, and what it does is it takes a words, and for each word in the words list, what it does is it initializes the neighbors, and it checks whether it is whether the other word whether other word is in each iteration it again iterates the array again, and at the second iteration it checks whether the word from the first iteration matches it or not. This means it's the same, so we skip over that iteration. Otherwise we check whether the word is neighbor or not through this is neighbor function that I described in task 1. After we have populated the neighbors, we simply perform um, hybrid sort. Let me run this, and yes, it runs without any error. For the task 6, we simply write data into our output file. The write data function takes the words, which are the list of words, and a file name, which is the name of the file where we should store our output. It simply opens the file as with write access, perform sorting, and uh, writes them with their uh, string representation, which I described in task one. That was it for my presentation. Thank you.